Hello Year 8. So today we're going to look at, or carry on looking at transpiration from last lesson and to develop our understanding in terms of remembering the definition and then thinking about what can affect the rate of transpiration and how plants can attempt to prevent wilting and things going wrong. So, little starter activity. See if you can come up with the answers to these questions. You should be able to do the first one easily, but then think about why it's important and why might it cause problems for the plant. So give yourself maybe 5 minutes thinking time, answer these questions in the back of your book. Pause the video here and then carry on in a moment. Okay, so hopefully you got the idea that transpiration is the evaporation of water from the surfaces, and the key thing is then the loss of that water vapour, which is the gas. Water is a gas, water vapour, by diffusion mainly through the stomata into the atmosphere. Why is it important then? Well, the whole point of transpiration is it's what creates the pull to bring the water up. Remember we had this diagram last lesson. So the water is absorbed by osmosis. This process is called osmosis in the roots, but then it's pulled up the stem through the xylem by the water being lost from the leaves. So that's why it's really important. And that means water can get to the top of the leaves to be used in photosynthesis, and it can also help keep the plants what we call turgid, which means firm, standing up straight, so the leaves are all pointing at the sun so they can do as much photosynthesis as possible, all those sorts of things about support. And also that evaporation of the water can actually help cool the plants down. If you're ever in a hot place, if you go and stand under a tree, you've got the shade of the tree, but also the evaporation of water coming out of the leaves helps to cool the air down a little bit. So why can it be a problem? Well, because plants get water from the soil, if they can't get enough water from the soil to replace the water that's being lost in transpiration, they're going to start to suffer. They are going to wilt, their cells will stop being all firm and get all soft, and they might shrivel up and die. Okay, you can't really stop transpiration entirely because the plants have to open their stomata for gas exchange, for photosynthesis. So it's also inevitable, but sometimes too much transpiration can be a problem. So what I want to think about is, well, what's going to affect the rate of transpiration? So remember, transpiration is really about evaporation. So what you should think about, if you wash your clothes and hang them out to dry on the washing line, what conditions are going to make them dry the fastest? And how might that link into transpiration and problems for the plant? So again, have a think just for a minute or so. Just think about that middle question. What's going to affect how quickly your washing dries when you put it out on the line? Okay, so there's the question again. So key things: you expect your clothes to dry fastest on days that are warm, windy, and when the air is dry, which is called humidity. So humidity, you sometimes go, oh, it's very humid today, so you feel the air sort of feels damp. It can be very humid when it's warm or when it's cold. Okay, so humidity is just a measurement of how much water vapour is in the air, and the more humid it is, the more difficult it is for any more water vapour to go into the air, so the more difficult it is for water to evaporate. So if you want your clothes to dry really quickly on a warm and windy day, so the wind takes the water vapour away from around the clothes so that more water can evaporate, and the air to be relatively dry. Okay, if you think about this, why does using a tumble dryer make your clothes dry more quickly? It's because a tumble dryer heats the air up, and also the air is moving. Okay, so it's taking that moist air away, so it's keeping the air around the clothes dry. Key thing is the rate of transpiration is not constant. It's not always the same. Okay, and remember, transpiration is a pull, like pulling water up a straw. So sometimes the pull's stronger, sometimes it's weaker. Okay, and that speed at which the plant is losing water is called the rate of transpiration. Remember, anything we see, the word rate just means speed, how quickly something's happening. Okay, so the key factors we've already mentioned are humidity, temperature, wind speed, and also actually light intensity. So on the next slide, a big table of information. You can use that table to make some notes. Okay, so what we've got here, we've got light as the first thing. Now, key thing is when it's light, the plant's going to be photosynthesizing, but that's not really why it's affecting transpiration. It's because the plant needs to photosynthesize, needs to get carbon dioxide in and let the oxygen out. The stomata tends to be open when it's light. Okay, so that means water vapor is going to escape, so there's going to be more transpiration. When the temperature is higher, you've got more evaporation and faster rate of diffusion, so your rate of transpiration is going to be higher. So if you're drawing a little, let's do a little, draw a little graph. So if we had a little graph here, okay, of temperature on the bottom and the rate at the side, the higher the temperature, the faster the rate of transpiration. Similarly with wind, okay, when it's windy, you get higher rate of transpiration because it's removing the water vapor away from the plant, so it's allowing diffusion of water vapor to be faster. So again, when you have the wind on the bottom, let's see if I can type wind. The faster the wind, the faster the rate of transpiration. There's actually a bit of a kink here, but you don't need to worry about it. So the faster wind speed, the more the transpiration will happen. But humidity, the higher the humidity, the more water vapor in the air, the slower the rate of transpiration. And actually, if the air is fully saturated with water vapor, can't get any more in, then you don't get any transpiration at all. So if it's really, 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 really humid, you get very little transpiration. Okay, so spend a bit of time just making some notes on those ideas. Pause the video here, 10 minutes. You can do this as a table, little graph with some annotations, bubble diagram, whatever you like. Okay, so what happens if a plant is losing water vapor too quickly? Okay, so key thing is if a plant is losing too much water, more than it can be replaced, it will wilt. Okay, so you can see here's a plant which is nice and what we call turgid, so the leaves are all standing up, sort of nice and flat, so they'd be facing the sun coming down to them. Okay, but when they start to lose, so this pot's drying out, not got enough water to replace the water being lost, the leaves wilt and they sort of collapse downwards. Okay, and also the stomata, the holes, which you can see here shown really large. Okay, the hole, the pores, will close up because the cells around, which are called the guard cells, will lose water themselves and shrivel up, and that closes the hole. Okay, so the less water vapor is going to come out. It's also going to restrict carbon dioxide getting in for the plant to photosynthesize, but when water's really running out, it's more important to stop any more water being lost, so they close the stomata. Okay, so key things here, wilting is a sign of stress on the plant. If you've got a plant at home that's wilted, you need to give it some water usually. Okay, but actually the wilting itself reduces the surface area of the leaf, so they're going to lose less water vapor, and you can see they're all rolled up a little bit. Remember, most of the stomata are at the bottom of the on the bottom of the leaf rather than the top, so it's sort of trapping the bottom of the leaf downwards, so reducing the water vapor being able to get out. And you've got smaller holes, the stomata are closed up, so we're going to reduce the surface area. Okay, let's write a couple of notes on that. Pause the video. Okay, so last little bit I want to do is, well, what other things can plants do? How might plants be adapted to reduce transpiration? So actually how they physically grow, depending on the conditions they're evolved to live in, they might actually have different characteristics. So can you think of any plants, maybe go and have a look out in your garden, if you've got a garden, look at different plants and what features might they have that might help them reduce their water loss? Have a think for a couple of minutes. Okay, so maybe you came up with things like, what if they've got a really thick waxy cuticle? So the wax, remember, on the outside of the leaf helps prevent water from leaving the plant. Okay, reduces transpiration. So plants with really, really shiny leaves have a lot of wax on them. That's going to reduce the water that's leaving through other surfaces other than the stomata. So that's going to help reduce water loss. Plants can actually also have different numbers of stomata. So plants that live in sort of areas where there tends to be plenty of water available, quite often have more stomata because that's going to help allow for gas exchange to get more CO2 in photosynthesis. Now this picture is taken with the same magnification, so we're looking at the same area of leaf on the bottom here. See, this plant here has fewer stomata on it, so this might be a plant that lives in a hot country, this might be a plant that lives in a cooler country with more water available. Okay. Some plants are hairy. They often look white. Actually, if you go and look at when you're back in school, you might look at outside room 18. There's lots of plants there that are really silvery in colour, so their leaves are hairy. And so they are trapping water vapour around the leaf, a bit like wearing clothes. It's going to trap air, and you wear your clothes to trap warm air around you. Here, the hair or fur, if you like, is trapping moisture, water vapour around the leaf, so stopping as much water vapour being lost. Okay, they also look silvery, and that's going to reflect heat from the sun, so they're not going to get hot, so less water is going to evaporate maybe. Okay, then you've got real extreme adaptations. So we've got cacti here. You can see they don't even have leaves. The whole stem is where photosynthesis happened. Their leaves have sort of been turned into spikes. Now the spikes are there to stop herbivores and animals eating the cactus, because there's just full of water in here. There's a storage, and you can see they've changed their shape. They don't have any leaves, and the whole stem's really big and fat to store as much water as possible and reduce their surface area relative to their volume, so they don't lose as much water. They also have thick wax cuticles, etc. Things like pine trees as well. You might think of pine trees as being specially adapted, but actually they tend to live in countries that are quite cold, but it means the soil's sometimes frozen and the water's not available. So actually their leaves have been turned into spines or needles, and these have a much lower surface area. And in fact they're actually rolled up leaves. They're sort of spiraled round on themselves, and that means that the stomata are on the inside of this spiral, and that means the water vapour doesn't escape quite as easily. Okay, so loads of things you might think about, and you'll come back to this in Year 9 and Year 10, looking at adaptations to prevent transpiration. But you can just make a couple of bullet points or a bubble diagram, or find some pictures and just annotate them about these ideas. And that's going to be the end of our session today. Thanks.